Welcome to Thursday. Unfortunately, due to a family illness, I'm not able to come in today, and I didn't want to leave you hanging with nothing to do, so I decided to convert one of the Project Lead the Way PowerPoints into a video that we can use to keep going and move the class along. For today, I expect you to turn in Activity 1-4, the product innovation sheets from last class, the conclusion questions from the beverage container. We're going to go through the presentation and show you several design processes, but in particular go over the one that Project Lead the Way currently teaches its students. We will look at a video called The Deep Dive. It's about a design firm in California called IDEO and how they approach the design process. And along that, there is a packet that's Activity 1-5 that the substitute will hand out before we view the video. And you will follow along and answer the questions as we go. In addition, if time permits, there is a follow-up interview with David Kelly, the founder of IDEO, that's actually quite interesting. It comes back 15 years after this video. The original video, the deep dive, it dates back from the late 1990s, but the process, the way they approach design challenges is perfectly valid today. And if we get a chance to go ahead and watch the fourth part of this video, the follow-up interview, you'll get to see that it's been doing quite well for him. And so he's a quite interesting individual, very insightful. One of the greatest things we still have going for this country is our ability to innovate, and with individuals like him leading the forefront of innovative thought, it's quite encouraging. In addition, your engineering notebook should already have items, parts of activities 1-3, activity 1-4, and today's notes. These are the three things I will be grading when I collect engineers' notebooks sometime next week. So please, I do expect you to follow along with this presentation. I do expect you to take notes. Since this is the video format, I will pause and ask the substitute to go ahead and click pause so that you can copy down the things I've highlighted. As a PowerPoint, I will highlight things so you don't have to spend there hours trying to copy everything. So let's go ahead and get started. The design process, a design process. These are the topics covered in this presentation. What is design? What is a design process? Some examples of design processes, and in particularly the design process used by Project Lead the Way in IED. Yes, the word design is often used as a generic term referring to anything was made by conscious human effort, meaning everything around you has been designed. So great. It also refers to the process that is used to systematically solve problems. Fantastic. The formal definition that we will be using, and you may see pop up on test, quiz, or other, is the following. Let me grab a highlighter. Design process is systematic problem-solving strategy with criteria and constraints used to develop as many possible solutions to solve or satisfy human needs or wants, and to narrow down the possible solutions to one final choice. I will go ahead and pause now so you can copy this. All right. We resume, go back to pointer, arrow. So here are some examples. Is there only one? No. Depending on the textbook, depending on the course, depending on the company, many companies have their own different approaches, and many classes will teach you different methods. Here's one out of this textbook with design and problem solving and technology. You have 9 steps from identify the problem to frame a design brief. We'll talk more about design briefs. To all the way down to test, evaluate, and finally redesign and improve. Let's look at another one. Here you have from engineering, drawing, and design, identify the need, very similar to the other one. Define the criteria, means what are your parameters or your limitations, and so forth, all the way through to you eventually get down to something like redesign and improve. You're done, you have your final solution. This was originally Project Lead the Way first approach to a design problem, a systematic 12-step approach, an easy 12-step approach to design. Unfortunately, got a little unruly, a little long, and some of them got a little blurry. They tried using the wheel as a mnemonic. So ooh, look at all these different steps. But it was really bulky and cumbersome. So they streamlined the process. Now we only have 6 steps. Define the problem, generate concepts, develop a solution, construct and test a prototype, evaluate the solution, and finally present the solution. And through each one of these, there'll be checks and questions asked whether something's viable, which is possible, a solution is valid. We'll go through each one of these and highlight them. The first one, well, first of all, this is design process use ID is only one example of a design process. It is not the only one. Depending on where you go, depends on what school you go to, depending on what firm you work with, they will have their own. But the important thing is this: consistently applying a single clearly defined process will provide you a basis for understanding. It will give you a systematic approach to be able to approach all the problems in this class. So right off the bat, we're going to define the problem. There's my first option. Step 1, define the problem. You have to identify a problem, validate the problem. Is this problem a valid problem? Justify, sometimes yes. Is the problem we're solving? Not everything is a crisis, unfortunately. And finally, create design requirements. Eventually create a design brief. So step 1, define the problem, where you identify it and validate it. Under validate, who says it's a problem? What are the needs and wants? And more importantly, are there prior solutions? To eventually be able to create something called a design brief. Now that it's in red to begin with, this is going to come back repeatedly in this class. I will pause now. Alright, let's continue. As part of the design brief, as an explanation, a design brief, it's a written plan that identifies a problem that can be solved, its criteria and constraints. It is used to encourage thinking of all aspects of a problem before attempting a solution. We'll go ahead and skip this part. Just know that define problem is the first step. We'll come back to the design brief in greater detail. So, once we've defined the problem, is the problem valid and justifiable? In some cases, it's not. If the problem is not valid and justifiable, the designer must define a new problem. In other words, maybe you haven't been given clarity. Maybe this problem brought to you is not pressing enough. In which point, if it's not, the project lead the way process design steps say, well, if it's not, you branch back up and redefine the process again. You go, no, you think about it. You go through this process. You find that there's other ways you can focus. Step 2, generate concepts. Generate concepts. What does that sound like? Doing research. Brainstorm as many possible solutions. And generate concepts, you research, brainstorm, consider additional design goals, apply STEM principles, and ultimately select an approach. We'll use something called a decision matrix. We'll come back to decision matrices down the line, but a decision matrix is a way to be able to judge and evaluate ideas. So under generate concepts, step 2, these are all the things you would do. I will pause here for a moment. Alright, let's continue. The decision matrix is an example, a tool used to compare design solutions against one another using a specific criteria. It's literally an assessment chart. Oh look, here's all my possible ideas. Which one is the best one? I come up with categories, I assign values to those categories, and then each idea is weighed against a category. In the end, it's an impartial method. Oh look, which idea scores the highest? Based on here, idea 3 has a score of 10, therefore it must be the overall best solution. We'll come back to talk about decision matrices later on. But right now you have the highlights for generate concepts. And as with always, within the generate concepts, does the needed technology exist? You may be coming with outlandish ideas that, you know what, there is no anti-mag levitation technology yet for beverage containers. So maybe we have to do a little research. If the technology does not exist, you may have to do some research and start the process over. Come back to redefine your problem or come up with more ideas. But hey, if you already have all the tools available based on what you brainstormed, based on what you researched, based on what you looked up, and based on the idea you selected, you go on to step 3. In step 3, develop a solution. You do start, this is where you have your one idea selected. Now you start creating detailed design solutions. That includes items such as be able to justify why you're doing this particular one. You feel confident about the idea. You have clarity. This makes the most sense. This looks the best to you. Decision maker says that, and you start also coming up with something called technical drawings. Now you're really sketching your solution out. You're not just quick doodles on a paper as part of the brainstorming process. You're actually developing technical drawings. You're creating prototypes. You're creating multi-viewed sketches. We'll talk about multi-views later too. Technical drawings, as explanation, technical drawings provide technical information as you produce the product. Meaning, they're the blueprints. They're the documentation you'll send to the machinist, to the prototypers who will actually use to create your models, your first working prototypes. Is the solution valid? Well, after you've developed the solution, is it good? If a solution is found to be invalid or cannot be justified, the designer must return to the previous step in the design process. You made some, you went above and beyond and made something that was outlandish, a little too pricey. So, is it valid? It can be justified? No. Go back to somewhere along the design steps, either redefine problem, maybe generate more ideas, maybe develop a solution. But if the solution is valid, it's justifiable, it's practical, it's time to build a prototype. Step 4. Construct a prototype. You, again, will construct a testable prototype. You will make plans for its testing. It's one thing to build a fully functional working model, and it's another thing just to throw it against the wall and hope it sticks together and say, yep, it holds up just fine. No. In design companies, once they make their prototypes, they have to subject it to tests. Those tests are controlled, regulated, so data can be reported, so it can be analyzed to determine if the product works. Such as performance is recorded, usability is recorded, durability. Those will be tested. Finally, you actually test your prototype. Once you test your prototype, you use it to collect data, and you analyze the test data to eventually generate a test report. Here you went through the whole process of defining your problem, generating ideas, developing a solution, creating a testable prototype, and at the end you present the results. Hey, the product held up wonderfully under field testing. It survived the outdoor environmental tests. It didn't, or conversely, maybe it didn't survive the testing. It could become a failure analysis more than just a test report. I'll pause here so you can copy. All right. Is the prototype valid? After all that, did it survive? If the test prototype cannot, if a testable prototype cannot be built or test data analysis indicates a flawed design, the designer must return to a previous step of design process. So if it was a miserable failure or it cannot be tested because there's no suitable means to test the solution, you bounce back along the process, either back to the find problem, and you start over. If it is a valid prototype, if it is testable, if it generates good test data and it survives and everyone's happy, you move down to the second and last step, evaluate the solution. And evaluate the solution, we see how effective your design is. Reflection on the design means you write your commentary, your opinion, recommended improvements. Yes, it's gone through its test process, and now you know what, you saw some things that could be added on there. You saw some things that need to be changed. It may have survived the testing, so it didn't ultimately kill the whole project, but you have to make some changes. And there we go, optimize and redesign the solution. Once you've had a chance to build it, test it, analyze the results, you know what? There's some deficiencies. It'd be nicer if the item did this. It'd be great if you can take care of that. And all that would be under project recommendations. As you can tell, I'm pausing. Okay, I'm no longer pausing. Once the solution's been evaluated and you've decided you've had your project recommendations underway, does the solution solve the problem? In the end, do you have a finished product that answers the step one way up the beginning? Does the problem solve? If not, designer returns to a previous step of the design process and continues. As you can see, this thing is geared so that along the way, if things don't work out, you have a way to punch back and go back and work into more. You get down a few steps, I'm having a little trouble here, you can punch back to a previous step. A little trouble here with the prototype, punch back on the previous step. Versus the previous project model, which was a circular wheel that you just kept moving forward, forward, forward. At the end, there was very little chance or very little practical way to see where you can reevaluate the design. If your solution does meet everything and everyone's happy with it, the last step, step 6, present solution. This is documentation of the project. For us in this class, it could be everything from your brainstorming sketches, ideas in your engineering notebook, daily journal entries, your work in Inventor, your 3D Inventor CAD files, printouts of those CAD files, final conclusion report. In some cases, you may even have a project portfolio to add to, and communicate the project. You may ask to present the project, or at least present it in a report format and turn it into me for our class. In design world, you may be presenting this in front of a board saying this is the final project, test results are favorable, we have a solution, gentlemen, let's roll out and make 10 million of them. I'll pause here. In fact, I do believe this is my last slide. So that said, you will, well, at some point we'll pause it here so you can make sure. I would love you to have these 6 design steps as shown here as a flowchart with define the problem. In fact, let's do this with define the problem, generate concepts, develop solution, construct and test your prototype, evaluate the solution, and finally present the solution. I'd like you to have this chart listed so it shows the progression from one step to the other, where you also ask yourself, are you still on track? Is the problem definable? Do you have the technology you need? Is the solution valid? Is the prototype valid? I will be looking for this flowchart as part of the engineering notebook check on this presentation. Now, for the rest of the day, you have before you activity 1-5, the deep dive. You will go to the class web page. There you'll find 3 links to the 3 different parts of the video. It's approximately 22 minutes in length. It was meant for a 30-minute show minus commercials, but the way YouTube broke it down, they're down to 3 10-minute segments or such. You will be allowed to use headphones if you have them, so you can plug into the computer and listen to the video just to yourself. Otherwise, you must make sure you turn up the volume enough so it only primarily you can hear it right in front of the computer. If we have all 29 machines blaring the video out of sync, it becomes a big mess of noise. No one can hear anything, so you need to tone it down so just you can hear it in front of you. That means you'll have to pay a little bit of attention. Headphones would be ideal for this case, so you can use them. If you want to sit with one other person at one computer to watch the video, you're welcome to do so. There are 30 students in third period, fifth period, and 28 of them in seventh period, but only 29 computers. So seventh period, you're covered. You can sit one per machine if you like. But I'll be nice. I'll even let you sit partners in that one as well. But for the rest of us in third and fifth, you can partner up with one other person. That way, two of you huddled side by side can watch one machine, then you leave a little space between, and suddenly it's not such a big mess in terms of noise. You will watch the videos. You will answer the questions. Some of them are literally verbatim. Others you'll have to watch and listen and pause and think about what they said. There is a section about a design brief, and you'll see an example one. The item they're building, they created a guiding document, something that lists specifically criteria. What was the problem in the world? What was the challenge? Try to fill that out to your best of your ability. Give it a shot. We're going to talk more in detail about design briefs, and as such, I need you to at least give one a try. This packet is due at the end of the period, and I'll look at them when I get back on Monday. You'll probably get it back, so we continue on a little more, start talking about the design brief itself, and see what we need to pick up. So that will probably hopefully take you to the end of the period. If you've got everything done, the whole thing is all finished, you turn in activity 1-4, you turn in activity 1-5, your engineer's notebook is up to date, even ready to go. If you're comfortable saying your engineer's notebook's ready to go and even up to date, you may even turn that in today as well and give it to a substitute. I will collect it all hopefully Friday and go through it, and you may be one of the first people to get your engineer's notebook back with 3 additional scores. So go ahead and take to computers. Thank you for watching. I know it wasn't ideal, so this is my first time using this, so hopefully it wasn't too horrible. All right, take care. Have a good weekend.